Hey guys, welcome to another A-level maths, or A-level further maths revision video. We're doing some core pure revision today and roots of polynomials. So let's take a look at what we've got. Try to pick out a nice variety of questions here. So this first question, a very standard exam style question taken from the exam paper at the end of the core pure 1 textbook. So let's get the pen. Let's have a look at tackling this. So we've been given this cubic equation. Without solving it, can we find the cubic equation which has these roots here? So 2 alpha minus 1, 2 beta minus 1, and 2 gamma minus 1. So we need to find this new cubic here. So how do we do this? Well, let's take this cubic equation we've got here, and let's consider the roots that we know. Well, we can rewrite this using substitution here. So let's just say w, so this is a very common letter we use here, w, that would be equal to, say, just 2x minus 1. Okay. To replace an either alpha, beta, or gamma with x, so 2x minus 1. And then let's rearrange this for x, because once we've got x, we can just substitute it back into our cubic equation. So x, hopefully, just nice and easy, just rearranging this in terms of x. That'll be w plus 1 divided by 2. Okay, so that's what x is. So all we need to do here now is sub that into this equation here at the top, this cubic equation. Okay, so what would that be? Well, that'd be 2 lots of x cubed. So that's 2 lots of w plus 1 over 2 cubed minus 3 lots of x squared minus 7 lots of x, which is this, over 2. And we've just got this minus 1 at the end here. Okay, and this is all equal to 0 now. So at this stage here, all we need to do is start simplifying. Okay, so let's just deal with this w plus 1 over 2 squared first, because once we've got this squared, we just have to times it by w plus 1 again to get the cubed version. So remember, if you're squaring a quotient like this, you can square the numerator and square the denominator separately. So for example, if I do w plus 1 squared, that would be w squared plus 2w plus 1. Okay, and then obviously if I want w plus 1 cubed, that would be this expression here times by w plus 1 again. Okay, let's just write this down just in full so we've got it. Okay, so what I need to do now is consider expanding each one by this, the number outside here, this constant. And let's deal with the powers. So for example, there's 2 lots of w plus 1 over 2 cubed. Well, that'll be 2 lots of. So if you expand w plus 1 by this here, so that'll be w cubed. So w cubed, you'd get 2w squared. That's 2w squared, and then you get plus w. And then expand the 1 across now, so 1 times w squared would be w squared. 1 times 2w is 2w. And then 1 times 1 is just 1. Okay. And then this denominator here, if you cube that, 2 cubed, that's just 8. Okay, so we need to simplify the numerator in a second. This one now, this minus 3 lots of x squared, that would be minus 3 lots. This expanded here is just this, so that's nice and easy. And if you square the denominator, 2 squared, that's 4. Okay, so that's nice and easy. Minus 7 lots of this, we won't do anything just yet with this. Just leave it like it is. Okay. So what I'm going to do now is I'm just going to rub out this line here and we can simplify it. So if you've got w cubed plus 2 lots of w squared plus w squared, that's 3w squared. So that's 3w squared. So let's just write it out in full here. So all I'm doing is just simplifying this numerator now. So that's 3w squared plus 3w plus 1. Okay, so once you simplify the numerator, this is the expression you should get. So at this stage here now, I want to try and get everything over a common denominator and then just multiply through by that denominator just to get it, just as the cubic that we're going to end up with. So the easiest one to end up here with would be the 4, right? 2 divided by 8, so I'll get a denominator of 4 here, got a denominator of 4. If I times this top and bottom by 2, we get a denominator of 4, and then just times that by 4. So, what we've actually got then here, so 2 divided by 8, so I get 1 over 4, so I've got w cubed plus 3w squared plus 3w plus 1 over 4 minus, so I'm just going to do minus 3 lots of, in fact I'll keep the minus on the outside for now, so this will be minus 3 lots of 3w squared plus 6w, so because I've kept the minus on the outside, everything's just positive on the inside for now, but obviously you'll times it out by the minus in a moment. That's over 4 as well. This here, so this would be 7w plus 7 over 2, and I'm going to times top and bottom by 2. So again, minus on the outside, this would be 14w plus 14 over 4 this time. And then just times this by 4 as well, that's minus 4. Okay, and that's all equal to 0. And then at this stage here, all I can do is just times through by the 4, get rid of this denominator of 4, right? So times each expression by 4, essentially you just get left with the numerators for each one. So if we take that up here now, we should have enough room. I'm just going to get left with w cubed plus 3w squared plus 3w plus 1. So then this time now we've just got minus the numerator, so minus 3w squared minus 3w squared, I think we're going to run out of room here, minus 6w minus 3 minus 14w minus 14 minus 4 equals 0. And then at this stage here, just collect like terms and we're done. So, simplifying this, well we've only got 1w cubed here, so it's just w cubed. I've got 3w squared here, got minus 3w squared there, and there's no more w squareds, so they just cancel. We've got 3w minus 6w minus 14w, so that would be minus 17w there. And then what else have we got? So we've just got plus 1 minus 3, minus 14 and minus 4. So if you collect all that together, what you should get is minus 20 there. Okay, and that's equal to 0. And then that's it. That is our new, that's the cubic equation that we needed to find there. So in that case, just matching up where the coefficients are with p, q, r and s. So that would be p equals 1, just w cubed. With no w squared there, so q is 0. R would be minus 17. And then finally s will be minus 20. So it's a little all over the place, but this is essentially what you should end up with down here. Okay, so that's what you're aiming for at the very end there. Everything a little bit of bubble. But that's 6 marks for that very standard exam, very standard exam style question. Make sure you're confident with this kind of material. Very, very common. Moving on to the second question here, it's taken from one of the old exams from the old spec here, so June 2016, IELTS, the International FP1 paper. So it's a quadratic, so again, like we said, I'm trying to pick a nice variety here. You can be asked for questions involving quadratics like such, so let's have a go with it. So question 9, we're told that this quadratic has the roots alpha and beta, so without solving the quadratic equation, can we find the exact value of alpha squared plus beta squared, and then alpha cubed plus beta cubed? So very, very standard type of question. So first let's work out alpha plus beta. So how do we do alpha plus beta? Well, for a quadratic like this, remember, it's minus b over a. So that's just your coefficients here, the quadratic. So that's going to be, in this case, minus 4, because that's your b, over 2. Okay, simplify that, you get minus 2. Okay, but we also need alpha beta, and we'll see why in a minute why we need alpha beta. So alpha beta, what is alpha beta? Well, that's just c over a. Okay, so the c is the minus 3, so it's minus 3 over 2. So why do we need to work these out? Well, because we want alpha squared plus beta squared. So how do we get alpha squared plus beta squared? Well, think about if you square alpha plus beta. What would you get? Well, that's going to be equal, so if we just do it at the top here. That's going to be alpha squared. That's going to give us beta squared, like we also need. But we end up with this extra term, because we end up with minus 2 lots of alpha beta. Okay, this is a problem. We don't want this. We just want alpha squared plus beta squared, like the question asks for. So in that case, sorry, that should be plus 2 alpha beta. So in that case, we need to subtract it. So that's where my minus is coming from, because we don't want that included. So we subtract 2 lots of alpha beta. Okay, we know what alpha plus beta is. That's minus 2, and we know what alpha beta is. That's kind of the reason why we've worked them out, right? So we can now use that fact to work out alpha squared plus beta squared. So that's minus 2 squared minus 2 lots of minus 3 over 2. So what's that going to give us? Minus 2 squared, that's 4. Minus 2 lots of minus 3 over 2. That's just going to simplify there. There's 2 will cancel. So it's just minus 3. In other words, plus 3. And then 4 plus 3 gives us 7. Okay, so alpha squared plus beta squared is just 7. And now let's have a go at working out alpha cubed plus beta cubed. So let's just clear all this so we're on through. Very kind of, or you know, it's exact, basically the same method here, but there's a bit more work because obviously we're working with cubics here. So what we're going to do is consider alpha plus beta cubed. And again, what do we need to subtract off this? Well, alpha plus beta cubed, I'd just use the binomial expansion for this. If you're confident with it, you can just expand the bracket as well. Either's fine. So again, just using the binomial expansion, this would be alpha cubed plus beta cubed plus 3 alpha beta squared, and then plus 3 alpha squared beta. Okay, so if we work that out now, what's that going to be? Well, at this point here, it's not particularly clear what you've got to do. But obviously, we need to get to this part here at the end. This 3 alpha beta squared and this 3 alpha squared beta. Well, how can I do that? Well, we can factorise. So we can write that as alpha cubed plus beta cubed plus, we can pull out 3 alpha beta from each one, like so. And we can write that as alpha plus beta. Okay, we know what alpha beta is, we know what alpha plus beta is, so we can subtract this off now, because we don't want this, we just want this. So essentially, subtract this part off. Okay, so we need to subtract 3 alpha beta times alpha plus beta. Okay, so alpha plus beta cubed, so that's minus 2 cubed, minus 3, so we do it all in one bracket, minus 3 times alpha beta, so that's minus 3 over 2, times alpha plus beta, which is minus 2. Okay, minus 2 cubed, so that's minus 2 times minus 2, which is 4, and then times it by minus 2 again, minus 8, minus, so this is 3 times minus 3 over 2, so that's minus 9 over 2, times minus 2, that would give us 18 over 2, that's minus 18 over 2, which in other words, this is the same as being minus 8, this simplifies to 9, so minus 8, minus 9, to give us minus 17. Okay, so alpha cubed plus beta cubed is just minus 17. So these, again, very common. If you see something like this, so it's, you know, like alpha squared plus beta squared, think about what you just need to subtract it off. And again, same for the cube powers. With enough practice, you will just kind of get used to this. You don't need to worry about expanding and such. But I would recommend that if you're new to these style of questions, write everything out in full, kind of like this, so you can see what's actually happening. Okay, well, that's that question done. Take a look at the next one here now. So this time we've got a cubic again, like we did in the first one. This time we're given that alpha beta plus beta gamma plus gamma alpha is equal to minus 4. So we need to write down the value of k. So 1 mark for this, you shouldn't expect too much work. So how do we do it? But remember, alpha beta plus beta gamma plus gamma alpha, that's going to be equal to c over a, right? If we write that out using our coefficient, that's c over a. Well, c, remember there's no x squared here, so it's just x cubed, then x, and then just our constant at the end. So our c is just k, and then our a is 3. So this is k over 3. We've been told this is equal to minus 4, so in other words, k over 3 is equal to minus 4. And then we just need to solve this, dead easy, times 3 by 3. So k is minus 12 there. Okay. So in other words, the actual equation we're working with is 3x cubed minus 12x plus 11 equals 0. So the next one asks us to write in the values of alpha plus beta plus gamma, and then alpha beta gamma. Very similar to kind of how we did with the last one. Alpha plus beta plus gamma. So you'll have to forgive my terrible gamma signs. I'm not good at writing them. That's going to be equal to minus b over a. Okay, minus b over a. Well, we have no b, right? The coefficient of x squared is 0. So this is 0 over 3. In other words, just 0. I'm not sure where my pen's gone. So 0. Okay. So nice and easy. Alpha beta gamma. What would that be? Well, that's just going to be minus d over a. So minus d over a. So what's the d here? So that's 11. So in other words, we've got minus 11 over 3. So that's just part B done there. And then for part C, we want to find the value of 1 minus alpha times 1 minus beta times 1 minus gamma. In this form, it's hard to work with. We don't actually know what terms we need to be multiplying from here and here. So what we need to do is get that into a form that we can actually work with. So let's do it at the top here. Times 1 minus gamma. If you're unsure, just expand the brackets and see what you end up with. Because there isn't really any other way I can think of doing it. So expand just 2 of the brackets and expand by the third one. So if I expand the first 2, 1 times 1 is 1. 1 times minus beta is minus beta. Minus alpha times 1 is minus alpha. And then minus alpha times minus beta, we get plus alpha beta. Okay. We just need to times all this now by 1 minus gamma. Okay, so 1 times 1, that's 1. 1 times minus beta is minus beta. Minus alpha times 1 is minus alpha. And then finally, 1 times alpha beta is alpha beta. And then do the same with the gamma here. So minus gamma. I'm going to run out of room definitely. Plus, because this is minus gamma times minus beta, so plus beta gamma. If I just do it underneath, so we're on gamma times minus a, or minus alpha, sorry, minus alpha times minus gamma, we get plus alpha gamma. And then this minus gamma times alpha beta, we get minus alpha beta gamma. Okay, so let's just collect everything that we know here. Well, this is 1 minus alpha plus, minus beta minus gamma plus alpha beta plus beta gamma plus alpha gamma, and then finally minus alpha beta gamma. Well, so let me just get rid of this just so it's not confusing. How do we actually work this out now? Well, we need to just basically get this into a form that we can manipulate. This minus alpha minus beta minus gamma, we can factor that out as minus 1. So what we've got here then is 1 minus alpha plus beta plus gamma. We know what that is. That's just 0. Alpha beta plus beta gamma plus alpha gamma. We also know what that is, but we'll just write it as it is for now. Because obviously that's what we've got up here, that's minus 4. And then this minus alpha beta gamma, again, we know what that is. That's minus 11 over 3. So now that we've got everything in the form that we can work with, we just need to substitute it in. So this is 1 minus, this is 0. This is minus 4. And minus alpha beta gamma, that's minus 11 over 3. Okay, so what you get left with here is 1 minus 4 plus 11 over 3. Okay, Work that out on your calculator, or do it by hand if you want. And we'll get 2 over 3 there. Moving on to the final question here, we have quite a nice one to finish with. So we've got this quartic equation. We've got the 4 roots alpha through to delta. So we've just got 3 parts we need to work out. So just change to the right pen colour here. So for part A, we're told that alpha, beta, gamma, delta is equal to minus 3. So we want to work out the value of A. Well, remember, alpha, beta, gamma, delta, that is equal to E over A. Okay, which we could write that as basically minus 6 here, because E is minus 6, divided by A, which we don't know yet. That is just A, like we said here. But we know this is equal to minus 3, so using that information we can solve it. So minus 3A is equal to minus 6, so divide both sides by minus 3 to get 2 there for A. Okay, so now A is 2, we can work out the rest of the parts here. So sigma A, well that's just minus B over A. Okay, so these are just standard results here. So minus B over A, so that's basically minus 3 over 2. Remember this B, the A, B, C, D, E, these are just your coefficients here, the quartic. So that's just minus 3 over 2. Sigma AB, what would that give us? That gives us C over A. And what's that equal to? By the way, I'm doing this wrong. This should be alpha. This should be beta. Same with this should be alpha. I'm not with it today. But C over A, so that's going to be 2 over 2. So 2 over 2, which we know is obviously just 1. And then finally, sigma, alpha, beta, gamma. There we go. We're getting there. That's going to be minus D over A. Okay, so that's basically minus 1 over 2. Okay, so them are the 3 parts that we need there. And then for part C, just a little one. I want to find the value of 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. Okay. Normally there's quite a bit of work to this, but it's quite nice for this one because we've got sigma, alpha, beta, gamma. And remember, if you want 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta, we could just write this as the sum here of alpha, beta, gamma divided by alpha, beta, gamma, delta here. Okay, so we know what each one of these is worth. Alpha, beta, gamma, the sum here, that's minus a half. We divide this by alpha, beta, gamma, delta, which we know somewhere, where do we write it? Yeah, there we go, minus 3. So we divide that by minus 3. So in other words, this is just 1 over 2 divided by 3, which is 1 over 6. Okay, so that's all you've got to do for the last one there. So that brings us to the end of this video. I hope this hasn't been too bad. If there's any mistakes, which there could possibly be, please just let me know down below. Cheers.